Hello, everyone. My name is Ben Hopp. I'm a senior solutions architect with Imply. I am the first solutions architect. I've been with the company for a little bit over a year now. Prior to Imply, I was with Hortonworks, also working in the big data space. But I've been doing this a while, and my days are filled with lots and lots of Druid. So I figured I'd give you guys a little taste of what it is I do. But before all of you leave, the Druid Summit coming up April 13th to the 15th. This is our first kickoff summit, and we are offering pretty hefty discounts to all meetup attendees. So grab me or any one of the Imply guys if you're interested in coming out to San Francisco and talking about Druid. We have lots and lots of speakers, and we're looking for more if you guys have an interesting case that you'd like to display. So what is it you would say you'd do here? Well, I do 4 different things. I do education. I teach people about Druid. I make recommendations on how they can best implement and make use of the technology. I actually do hands-on keyboard work and implementation. And then I take their implemented code and make it production ready, do things like security, operationalizing the code. So the first thing I do when I visit a customer is I ask a lot of questions. I want to gather as much data as I can. Oftentimes, a customer comes to us with a problem, and they think that they know what's causing the problem, but it takes peeling away some layers to find out what the root cause is, because the problem that they're experiencing is rarely as direct as they believe it is. So we ask questions like, what is the use case? Is this something that you should be using Druid for? Who is the end users and how are they interacting with the cluster? Where is the data coming from? Are you using streaming or batch data, Kafka, Kinesis? Are you on a really old version of Druid and using Tranquility? What are the issues or concerns that you have, not just with the problem that you're having, but also with the system as a whole? Echo. And where does Druid fit in the technology stack? I'll talk about that a little bit more in a bit. So first up, determining if Druid is the right solution for you. So Druid does a lot of things really well. It kind of pulls from the best features of a OLAP system, a time series database, and a search platform. So if you have data that is organized around time, if you are doing slicing and dicing of that data for user-facing analytics, and if you're doing full text search, these are all kind of the markers of a good use case for Druid. And when should you run away from a use case? That's a little messed up. If you are looking at OLTP, so if you're doing individual line or record level updates and deletes, that's usually not a good fit. You're doing really big join operations. You're joining fact tables to fact tables. That's usually not a good fit for Druid as well. This is not a replacement for your entire big data platform. Rather, this is a specialized tool to really accelerate the slice and dice analytics of data. Where it fits in the technology stack, like I said, it's not meant to replace Hadoop or Hive or Presto. It is meant to augment those systems because they're not able to do what Druid can do. They can't do sub-second queries over these billions or trillions of rows of data. It works along with Kafka or Kinesis as well as Hadoop for a Lambda architecture, and it typically powers user-facing applications. So one of the first things I do after asking all of those questions to the client is I do a cluster evaluation. This means I go through and actually evaluate how the cluster is set up and if there's anything that can be done at a cluster level to improve performance. So you saw this slide previously. I'm not going to talk too much about it. But what I will point out is we have services. Those are the items in yellow, servers, which is the items in blue, and then external dependencies in brown down there. All of those services can be broken out and run separately. They don't necessarily have to be deployed in this arrangement, but we found that for most clusters, this is a logical way to lay out your services. So picking your servers. Masters nodes, it sounds like these need to be like really big because they're called masters, but really you don't need that big of a master node. Usually you can start with a fairly small node, and then as you add more segments or more real-time ingestion task supervisors, you scale out your master nodes. Your query nodes, usually these are kind of medium-sized. They scale out as you add additional users or as you add additional data nodes. Usually we go one query node to about every 10 or 15 data nodes. And then the data nodes are the workers. These, as much CPU and memory you can throw at them, they will love you for it. Next up, once we determine that the servers we're using are appropriately sized, we have to make sure that the configuration is appropriate for those servers. So this is by no means an exhaustive list of all the settings that need to be evaluated, but usually when I come into a brand new cluster, these are the things that I adjust first. The important ones, obviously making sure your heaps are appropriately sized, making sure your connections and threads are appropriate to the machine, read the documentation. It goes through all of the sizing exercises for this. Typically, we'll disable caching at the broker level and enable it on the historical level. If you have a really small cluster or limited use case, sometimes you can get better performance by switching that. But when we're going to production, we usually disable it at the broker. Next up, after we've made sure the cluster is in a healthy position, we're going to take a look at the data that they're loading on that cluster. And one of the most important tools to this job is the unified console. If you are using an older version of Druid, you probably have the coordinator and overlord console. Unified console makes this process a lot easier. One of the things that does that is it gives you the average segment size right here. You can calculate average segment size manually in the old version, but I'm lazy and I like it right there in front of me. So earlier, they talked a little bit about this ideal 300 to 700 megabyte segment size or 5 million rows. Well, there's a lot of tuning that goes into kind of achieving that ideal segment size, such as adjusting the granularities, partitioning, and compaction. So we'll talk about those a bit. First thing we tune is the number of tasks. And this is specific to real-time ingestion, Kafka Kinesis. You don't want to just throw a lot of tasks at your ingestion. That tends to create very small segments. So you want to have the minimum number of tasks running that will keep up with the data volume that you're ingesting. Next up is the segment granularity. If you are ingesting only one file per segment, and that one file is less than 200 meg, you probably want to increase that. So if your segment granularity is set to hour, and in 1 hour you don't receive 200 megabytes of data, I want to kick it up to a day. Now that's pretty uncommon, at least in a production use case. What's more common is your max rows per segment. So if you are receiving multiple segment files in that period, each of them is the default amount of 5 million records, and you're still less than 200 meg, then you go ahead and increase that max rows per segment. Now, if you're ingesting a bunch of theta sketches, chances are you're going to be in the opposite situation. You might have large segments, and you might need to lower that max rows per segment. Finally, compaction. This is really useful if you have late arriving data and you are getting very small segment sizes because your data is being appended to previous segments. So if you submit a compaction task, it'll take those little segments and merge them into one. You can also set up automatically scheduled compaction tasks so that it evaluates the segments for you. Next up, and Ty talked about this before, the roll-up, making sure that we can get the most efficient use of our Druid cluster by aggregating that rows at ingestion. So you saw this diagram earlier, where it takes multiple records with the same dimensions and pre-calculates the metrics for it. Also, we can use those sketch objects to do cardinality or count distinct operations. We'll drop this user ID column and add a sketch column so that we can maintain the ability to determine how many unique users there are without actually maintaining every individual user ID in the data. Next up, I'll look at their column types. Um, this is specifically for dimensions, not metrics. All metrics are obviously numeric. However, there are times that you want to store a numeric value as a dimension, such as a user ID or customer ID. Those of us coming from a database world may think that storing that as an integer is going to be the most efficient way. Integers take up less space, less memory. However, those are not index values in Druid. So by storing that value as a string, you actually get the bitmap index generated, and you'll get much faster filtering on that column if it is stored as a string. If you're doing aggregation or ranges, so if you want to look at all the customer IDs that are between 1,000 and 20,000, then you'll probably get better performance with a numeric. Next up is secondary partitioning. This is exclusive to batch indexing. So if you have all data sources are segmented by time first, but you are able to add a secondary partition. This is really useful if you have a frequently used filter criteria, such as a customer ID or a project ID that you're working in a multi-tenant environment. By re-indexing the data with that partition value, you're able to get much better data locality, better performance, better compression, all good things, no bad things. And after we have determined that their cluster is set up correctly, their data is set up correctly, we look at how they're actually querying that data. The key here is gathering data. We don't want to make guesses about how they're using their data or how they're querying their system. We don't want to take their word for how they're querying the system. We actually want to see how they're querying their system. So by using the Druid metrics that are emitted from the cluster, we can actually look at their average query time. We can look at how much CPU usage there is, how much memory usage, and we are able to really drill down to the cause of any performance issues. This is also critical to determining if the changes that we make are improving the system. So doing that A/B testing with configuration changes. So make sure you're gathering your metrics, make sure they're in a system that you can easily access. When possible, use Druid SQL, especially for user-facing applications. This makes it much easier to use Druid. It makes intelligent choices about query type. You don't have to know the inner workings of Druid to write a SQL query. Of course, there are some limitations, but those limitations are always shrinking. Even this slide is out of date since multi-value dimensions are now supported, but there are still some aggregations that are not supported in SQL. We're constantly adding more and more to it. So I'm terrible at writing native queries, so the explain plan feature is very useful, where you can take a SQL query, explain, and get the JSON representation for it. The important thing there is you can tell what type of query that SQL query is actually running. So there's a number of different query types in Druid. Using the most appropriate one is important. There's a lot of kind of overlap. For instance, the group by and top n. Top n is kind of a subset of group by if you're using a single dimension to do a grouping. It's a limited list. Top n will give you much better performance, but group by is more flexible. You can group by multiple dimensions and do any type of query you want there. Select queries have actually been deprecated. Those are no longer available as of Druid 17. We've replaced them with scan queries. They're much more efficient and put much less pressure on the brokers. Finally, using lookups where appropriate. So obviously Druid doesn't support joins yet, but if you do have data that is changing over time, or you want to do data enrichment, using lookups allows us to address slowly changing dimensions and those kind of star schema use cases. They can be loaded from flat file or JDBC. They are loaded onto the Java heap. So if you are using a lot of large lookups, increasing your heap size is important. So that is basically my approach to dealing with a brand new customer that may want me to evaluate their cluster. Feel free to stay in touch and visit our community, which druid.apache.org. There's a Slack channel on there. That's how we do most of our communication. Come out there. Next up is the Druid roadmap. So we're going to talk about the new features of Druid 17 and also some of the features of Druid 16. So who here is on a version older than Druid 16? People? Who's on 16 or 17? Cool. Okay. That one. Cool. All right. So we're going to talk about what just came out, what recently came out, and what's coming up ahead. So Druid 17 now available as of yesterday. It's the first release as top-level Apache product. We have been accepted out of the incubating stage. We're now a real boy. So Druid 17, biggest changes, native batch improvements. We can now ingest from those binary file types with the native indexer, can read from HDFS from the native indexer. We can do single dimension partitioning with the native indexer. If you're detecting a theme here, it's because we are desperately trying to move as many small to medium-sized use cases off of the Hadoop batch ingester. It's just a better user experience to not have to have a dedicated Hadoop cluster. For a lot of our very large enterprises, they already have Hadoop clusters set up that they can use. But when we have a new customer, cloud native, they don't want to deal with antiquated technologies like Hadoop. Lots of improvements to the automatic compaction. We're now able to do parallel compaction. We're able to do minor compaction, so we can compact intervals of data while data is still being written to them. A lot of performance improvements, such as parallel query merge on brokers, gives better group by query performance. Added support for SQL compatible null handling. We didn't actually add that in 17. We just fixed a lot of stuff that was broken with it. New emitter for metrics with Drop Wizard. New sys supervisors table. lazy loading, historicals, and security updates. A lot of bug fixes. I think almost 300 bug fixes went into this release. So taking a step back, Druid 16, this was released about 3 months ago. We're on about a quarterly release cycle for Druid. 350 new features, 50 contributors, released in September. So when I was out here last, I was given this presentation. Introduction of the parallel-based shuffle. Before, when you're using the native indexer, your output segment file size was determined by the input segment or input file size. Now we added a shuffle step so that we can better optimize that output segment size. Query vectorization. This is a under the hood improvement. Allows the segment files to be read multiple lines in batch. This is enabled at the query level. If you're on Druid 16 or 17, adding the vectorization true in the context will allow you to use this feature. We added the first iteration of the indexer process. This merges the middle manager and peon tasks into one process. Again, this is really useful for customers that are running a lot of supervisor tasks that oftentimes don't need as much memory as the peon is allocated. We improved the web console, new loading of data from Kafka and Kinesis in the web console, point and click reindexing, so you can reindex from an existing Druid data source in the web console. In Druid 17, that web console actually replaces the old overlord and supervisor and coordinator consoles. So lots and lots of stuff. All right, so now let's talk about stuff that is planned for the rest of the year. SQL joins. Everybody has been asking for joins. This is going to be the first release that supports SQL syntax for joins. We're going to be continuously adding more and more support for joins to get to more and more of those EDW type use cases. The windowed aggregations, again, were really great at this time series analytical type of workload. We're working more towards the data warehousing type workloads. One of the necessities for that is windowed aggregations. Dynamic query prioritization. Right now, to prioritize queries, we're limited to setting up different pools of physical resources. So you set up hardware tiers for your hot data, your cold data, or your data science use case and your BI use case. We want to make this more dynamic so that Druid can tell before a query is executed how many resources it's going to take up so that it can prioritize and make a long-running query not impact the performance of a smaller query. We're expanding vectorization support. Like I said, phase 1 of vectorization was in Druid 16. That added vectorization for time series and group by queries. We're going to be adding it for all of the rest of the queries as well. Brand new site, no longer incubating, so we have the Apache site. You can download the Imply distribution of Druid, 30-day free trial on all the proprietary stuff that Imply puts on top of it. And as always, we are looking for contributors to the code. So if you're a Java developer, you want to get involved, come out to our GitHub page, join us on Slack, come out to San Francisco, hang out at Summit, and finally, check out the Druid Days training that are posted online. So I buzzed through a lot of that because they already covered a lot of it. So now we have time for questions. Oh, those questions. Yeah. Yep. So the First phase is going to be adding SQL syntax to features that already exist. So right now we have a lookup function and you can do a subquery. Well, we're going to add inner join and left join syntax so that you can use those same functions with your BI tool of choice. So when you're hooking up to Tableau or Looker, you can use your SQL join syntax. Um, it, Correct. And you still have a lookup SQL operator. It's a lookup function right now, but this is actually going to add the SQL syntax to that, um, or the join syntax to that. Yeah. Yep. Oh, So when the JDBC connection for the lookups is not a live connection, so when you issue a query that uses a lookup, it's not actually issuing a query to the downstream database. That JDBC connection is used to fetch the results periodically to refresh the lookup that's actually stored in memory. So you set up like a 5-minute or 10-minute polling period. All of the nodes go out and fetch the most recent data and refresh their local cache with it. So you can use complex queries to build those lookups, but on when it actually fetches and get loaded, it's just a key value pair. Um, in addition, I guess the next phases of the joins are going to be moving more of the join logic off heap so that we can support bigger and bigger lookups, as well as distributed uh, map joins so that you can use a secondary data source as your join. So joining between data sources. And that's going to be partially done in phase one. It's just going to be expanded to larger tables in the future phases. Yep. Multi-index dimensions? Great question. I don't know. I haven't heard anything about it, but there's like 350 GitHub issues out there, so I can find out, but I don't know off the top of my head. I know they recently added the ability to uh, control what index, or if you use an index at query time, but adding multiple indexes on a dimension I don't know about. Sorry. Anything else? Yeah. Yep. Fact table to fact table. So a big join is anytime that the query that you're joining to, or the dimension table that you're joining to, is too large to fit on the target machine. So in a Hadoop world, you can break up joins and have multiple reduce phases. In the Druid world, we have to move the data that we're joining to every one of the worker nodes, every historical node. So if the table that you're joining is too large to be broadcast to every historical, then it's probably not going to be running in Druid, at least in 2020. We don't know what 2021 holds yet. Cool. What's that? Skew data? What do you mean by that? Yes, yeah. So anytime that you're doing a join, you have to have all of the values that you're joining, all of the lookups or um, the join tables have to be on each of the nodes, um, similar to a distributed table in Hive or broadcast table. Sorry. Cool. And I'll be hanging out for a little bit. If you guys have any questions that you want to not ask to the crowd or more specific things. And I'm always on Slack, so join up with the Apache Slack Druid channel. Feel free to reach out there as well. And if you want stickers, we got stickers too. What more can you want? All right, anything else? Oh. All right, well, thank you guys very much. It's been a pleasure, and thank you for welcoming me to Israel.